Hi guys. So today we are going to talk about the pharmacodynamics. So let's begin. Actually, I have completed the pharmacodynamics. So I will just review. I'll just review the point that I have covered in the pharmacodynamics. So where is it? Yeah, dose response relationships. So the concentration of the drug at the site of action controls the effect. Like how much is the concentration of drug, that much will be the effect. Okay, so the like for example, if you say that that the potency of the drug is about 25 milligram of milligram. Okay, so if that amount of drug is present in the effector organ, then we can see that we can have the maximum pharmacodynamic effect, okay, of the drug. So the magnitude of the drug effect depends on the drug concentration at the receptor site, which in turn is determined by both the drug dose of drug administered and by the drug's pharmacokinetic profile, like rate of absorption, distribution, metabolism, and elimination. So, so now we are going to discuss about the theories of relationship between the binding and response. So there is occupation theory. Occupation theory states that the response is proportional to the fraction of occupied receptor. Okay. So like receptor, we have if we have, suppose we have 10 receptors in the cell. Okay. So if all the receptors are activated by the ligand, then we can say that we have maximum therapeutic effect. Okay, so maximal response occurs when when all the receptors are occupied. Okay, graphing dose response curves of drug studied under identical conditions can help compare the pharmacologic profiles of the drugs. This information helps determine the dose necessary to achieve the desired effect. Dose response, which involves the principles of pharmacokinetics and pharmacodynamics, determines the required dose and frequency as well as the therapeutic index of our drug in a population. So, graded dose response relationships. As the concentration of drug increases, okay, the magnitude of its pharmacologic effect also increases. Okay, okay. So, plotting the magnitude of the response against the increasing doses against the doses of a drug produces a graph. The graph of a response versus the drug concentration of the dose. The graded dose response curve that provides information about the nature of drug receptor interaction. So graded dose response curve provides the information about the nature of drug receptor interactions. Okay. So graded dose response curve, a graph of increasing response to increasing drug concentration or dose. The effect of dose on, one second guys. बोल. अरे वो सिद्धू बोल रहा था तेरे को, पूछ रहा था मेरे को किस रुक में रखा पे. अभी नहीं, कल किया था उसने उसको. हाँ. हम्म. अरे वो थोड़ा चेंज हुआ प्लान में, छोड़ जाने दे बेटा. बाय बाय. That was my friend. So graded dose response curve, a graph of increasing response to increasing drug concentration or dose. The effect of dose on the magnitude of a pharmacology response, EC50, drug dose that shows 50% of maximum response. Okay. EC50 is the drug dose that shows 50% of maximum response. 50%. Okay. EC50 is the concentration of a drug that produces a response equal to 50% of the maximum response. The potency of the drugs can be compared with using the EC50. The smaller the EC50, the more the potent. Okay. Smaller the EC50, the more potent the drug. Two important properties of drug potency and efficacy can be determined by the graded dose response curves. The first property is the potency, a measure of amount of drug necessary to produce an effect of a given magnitude. That is, the concentration of drug producing an effect that is 50% of the maximum is used to determine potency and is commonly designated as the EC50. In the figure, the EC50 for drugs A and B are indicated. Drug A is more potent than drug B because a lesser amount of drug A is needed when compared to drug B to obtain 50% effect. So guys, what is this EC50? So क्या है EC50 की? अभी देखो, ये इफेक्ट है, ओके, दिस इज द इफेक्ट, ये ड्रग है, ओके। ये ड्रग मैंने ये ड्रग मैंने ये इफेक्ट को पाने के लिए 5 मिलीग्राम दिया, ओके। 5 मिलीग्राम ड्रग में दिया ये इफेक्ट को पाने के लिए, ओके। वही वही जो ड्रग है, मैंने दूसरा ड्रग लिया और दूसरे ड्रग को 10 मिलीग्राम लगा ये इफेक्ट को जाने के लिए। तो आप मेरे को बोलो कि सबसे पहले जो ड्रग ए मैंने दिया बंदे को, ठीक है, उसके अंदर कितना कितना लगा था? 5 मिलीग्राम 5 milligram of drug was required to obtain the effect. Whereas in case of drug B, the amount of drug required is more. Okay, so we can say that the potency of the drug A is more than B. ठीक है, so वही EC50 है. So अभी अगर एक ड्रग का EC50 कम होगा तो उसकी पोटेंसी ज्यादा होगी, ओके, ठीक है। सो द सेकंड डोज प्रॉपर्टी that can be determined from the graded dose response plots is the efficacy of the drug. This is the ability of a drug to elicit a response when it interacts with the receptor. Okay, so the maximal response Emax or efficacy is more important than drug potency. Okay, efficacy is more important than potency. Okay, a drug with a greater efficacy is more therapeutically beneficial than that is more potent. Okay. Maximal efficacy of a drug assumes that all receptors are occupied by the drug and no increase in the response can be observed more. Okay, ठीक। सो पोटेंशियल मतलब क्या कि क्या अभी देखो, मतलब पोटेंशियल ऑफ ड्रग टू इलिसिट एन रेस्पॉन्स, ओके। एंड एफिकेसी मतलब क्या कि अभी देखो, अपने पास फॉर एग्जांपल वी हैव 10 रिसेप्टर्स, ओके, 10 रिसेप्टर्स एंड द दसों के दसों रिसेप्टर जो है वो जाते हैं, एक्चुअली द लिगैंड बाइंड्स टू द रिसेप्टर, ओके। दसों के दसों रिसेप्टर जो है लिगैंड से बाइंड हो जाते हैं, ओके। तो फिर अभी आप मेरे को ये बताओ कि अभी if I increase the number of ligands, there is a drug, okay, will it increase the response? No, right? So we can say that the maximal efficacy of drug assumes that all receptors are occupied by the drug and no increase in the response will be observed if more drugs are added. Okay, which one is important while selecting a drug for therapy? Potential efficacy, absolutely efficacy. Okay. Drug X has more biological activity per dosing and equivalent and is thus more potent than drug Y and Z. Okay. Drug X and Z have equal efficacy indicated by their maximal attainable response ceiling effect. Drug Y is more potent than drug Z, but its maximum efficacy is lower. Hmm. The maximum effect that can be achieved with a particular drug, regardless of dose. So efficacy represents the ability of a drug to accomplish a specified effect, whereas potency reflects the amount of drug required to cause an. Okay, so potency is the amount of drug required to cause an effect. Okay, and efficacy is the maximum ability of drug to accomplish to accomplish is- to accomplish a effect, an important effect. A drug may have a high efficacy but low potency, or vice versa. Efficacy is determined mainly by the nature of drug and nature of the receptor and its associated effector system. Okay. Potency is determined mainly by the affinity of the drug for the of the receptor for the drug and the number. Okay, so this is important. So drugs may have high efficacy but low potency, or vice versa. Efficacy is determined by mainly by the nature of drug and nature of receptor and its associated effector system. Okay. Potency is determined mainly by the affinity of the receptor for the drug and number of receptors available. Receptor. Okay. If in nature of drug and nature of okay. So EC50 or ED50 is a median effective dose. TD50 is a median toxic dose. LD50 is a median lethal dose, and EC50, ED50, and TD50, etc. In graded dose response curves, the concentration or dose that causes 50% maximum effect or toxicity, or shows half maximal effect or toxicity. In a quantile dose response curve, such data provide information about the variation in the sensitivity to the drug in a given population. So, in quantile dose response curves, the concentration of or dose of drugs causes a specified response in 50% of population under study. KD, the concentration of drug that binds 50% of the receptor in the system and is useful measure of the affinity of a drug molecule for its binding site on the receptor molecule. The smaller the greedy, the greater the affinity of a drug for its receptor. Bmax, the concentration of drug that binds maximum number of receptors. So, this quantile dose response curve, a graph of the fraction of a population that shows a response at progressively increasing doses. Quantile dose response curves are useful for determining doses to which most of the population responds. Therapeutic index and therapeutic window, and okay. So therapeutic index of a drug is the ratio of dose that produces toxicity to the dose that produces a clinically desired or effective response in a population of individuals. Therapeutic index TD50 by ED50. TD50 is the drug dose that produces a toxic effect in half of the population. Okay. And ED50 is a drug dose that produces a therapeutic or desired response in half of the population. Okay. So पहले ऊपर था टॉक्सिक फिर था नीचे डिजायर्ड ED50 TD50 ED50 okay. It is determined from quantile dose response curves. So, the therapeutic index ratio of the minimum toxic concentration to the median effective concentration helps determine the efficacy and safety of a drug. Increasing the dose of a drug with a small therapeutic index increases the probability of toxicity or in, in, or ineffectiveness of the drug. However, these features differ by population and are affected by patient-related factors, example, pregnancy, age, organ function. The therapeutic window, a more clinically useful index of the safety of a drug, describes the dosage range between the minimum effective and therapeutic concentration or dose and the minimum toxic concentration of drug. For example, if the average minimum therapeutic plasma concentration of cephalin is 8 milligram and toxic effects are observed at 18 milligram per liter, the therapeutic window is about 8 to 18 milligram per liter. When the therapeutic index is low, it is possible to have a range of it is possible to have a range of concentrations in which the effective and toxic responses overlap. That is, some patients hemorrhage, whereas others achieve the desired two or threefold prolongation of INR in the treatment with warfarin or drug with a small therapeutic index. Agents with a low therapeutic index, that is, drug for which doses critically important, are those drug for which bioavailability critically alters the therapeutic effects. In case of penicillin with a large therapeutic index, bioavailability does not critically alter the therapeutic or clinical effects. Time, guys. Finished. Bye.